Okay, there's two things you need to be able to do. Everybody ready? You are going to be okay if you can do two things. So right now you're not okay if you can't do two things, but we can fix this because it's only two things. I need you to be able to explain the general concept of a significance test. Here's the general concept. We have a claim about a population parameter. You need to know what that sentence means. That's our null hypothesis. The claim about, but we don't need to say null hypothesis when we are explaining how a significance test works. We have a claim about a population parameter. Okay, you might have to explain what a population, but a thing that's true about the population. We have a claim. We draw a random sample and we see that it doesn't show that. It's evidence that maybe that claim wasn't true. You guys okay with that? But we know it's just a sample. It's just evidence. It's not proof. It's evidence. That's different. Right? If we took a census, we could disprove it for sure. A census is when we find out data for the whole population. But when we're doing inference, we either don't have access, it's impractical to do it, whatever. So we have a random sample that is contrary to that shows us evidence that may not be true. You guys okay with that? So we make sure that we meet our conditions. We don't have to say that in our general, statement necessarily. So what we show is we assume that claim is true, and we say if that's true, we find the probability of getting our results. And our conclusion is based off of. So here's the definition of a p-value. This is maybe of everything else in the unit, and maybe everything else going on forward. You need to understand what a p-value is. A p-value is if the claim were true, if the null hypothesis were true, it's the probability of getting our results. Okay, now, I need you to be able to write it out with a little more nuance than that at some point, but that's it. Our p-value is if the claim were true, it's the probability of getting the results we got. And that's the reason what we're trying to do is say we're not really saying how probable are our results, we're trying to say how improbable. How low is the probability? If the probability is low enough, we're saying if that were true, the chance of us getting this are really low. Less than 5% is usually our line here, right? And so if the p-value is low, since it was so improbable, we reject the hoe. We say that the claim was false. You need to be able to understand that, okay? That's not that much if you step away from all of the mechanics and all that. But you got to take time to work on understanding that. I'm going to give you guys a couple of videos to watch if you're still struggling. Hear it again, hear it a different way, whatever. Then the other part of inference is going to be our confidence intervals. So confidence intervals for us are just for proportions and means. Significance tests, there's lots of different significance tests out there. The confidence intervals are just for means and proportions. So our confidence interval says this: we are just trying to find out. We're trying to estimate a population proportion or a population parameter. We're just trying to find something out about the whole population. So we take a sample, we analyze the sample to give us a prediction. We know our prediction is not going to be correct. We know it's not going to be exactly right, right? It's an estimate. You guys know what an estimate is, right? It's not an answer. It's a, educated guess, right? Educated meaning we have evidence that we think it's about that. And then we say, okay, we also know that if we took samples, they would follow that model, whatever the model we're looking at, either a normal model or a t-model. So we're going to say, here's our estimate. And then we're going to say, we think we are within this far. So we're going to go so far each direction, and that's our confidence interval. So our confidence interval is our estimate. And the 95% confidence means 95% of the time, our interval will be right. We don't know if it's right or not. We have no way of knowing the population parameter, but we have ways to estimate it. So 95% of the time, we'll be right. It's not that p moves around, p is a value, but if we take different samples, 95% of the time, whatever interval we get from that sample will be correct, will contain p. Those are the two things. You need to know that stuff. Not for today, not for tomorrow, but for everything going forward, the rest of class, AP exam, our final exam. So if you get nothing else out of the course, understanding the overall structure, and being able to analyze the results. That's the thing. That's the thing. If we're at the end, I say, I'm comfortable with you passing the course, even though you really struggle with a lot of the nuance. If you understand those things, I feel like going forward, you've got something out of it that you can use, like something that's pretty high level. All right, those two things. I'll talk about yesterday's work in just a second. Let me get it.